how chemistry is used to solve various mysteries. Imagine you got a question in your head, if whether T-Rex ever fought with Allosaurus or not. These two are known to be the most deadliest dinosaurs ever walked on Earth. Now, is there a way to know? The way to know is to go back in time to dinosaurs era. But now, how do the scientists determine these events? Earth history is divided into several eras, epochs, and eons. And how do scientists do that? They climb up by analyzing the geological time scale, looking at going deep within the rocks of Earth's crust, excavating these fossil records buried deep within the rocks. The scientists are able to determine the time. A fossil buried deep within is more likely to be from older time. But how do we estimate which fossil belongs to which era or epoch? The answer lies in carbon dating. Let's talk about chemistry behind carbon dating. Now, when any living organism dies, it disintegrates and eventually forms some kind of rock or soil and gets buried into the earth crust over the time. Now, looking at its carbon content, the ratio of the carbon while it was living, and then starting from the decay, starting from the time of its death, and analyzing those samples by modern mass spectrometric methods, we can determine what amount of carbon is remaining in that fossil. And that based on how much of, particularly looking at carbon-14 isotope, the decay of it, scientists can determine the age of a sample. As we know, radioactive decay follows first-order kinetics. And also, it's a fact known that carbon-14 has its half-life of about 5,700 years. Now, if we do the calculations, if of the decay following first-order kinetics, we can arrive at that going back in time, it can analyze a sample only as far as 50,000 years old. But dinosaurs existed millions of years ago. So what do we do? That's a problem. But we can go beyond carbon. Though carbon dating can only take us back up to 50 to 60,000 years in time, but this application applies to other isotopes as well. The heavier metals like uranium and thorium, which have half-lives of actually billions of years, by analyzing their decay in an earth crust sample, which is embedded with the fossil record, we can analyze a sample and estimate, go back in millions of years in time. Thus, we can find out if T-Rex ever fought with Allosaurus or not. As it turns out, by the analysis of the rocks of Triassic and Cretaceous period, that these two dinosaurs wouldn't have crossed each other. There was no way they would have fought each other, as the entire Jurassic period was in between those two. Though we would like to know who would have won, but unfortunately they existed in millions of years apart. And chemistry and radiological carbon dating or isotope dating makes us know this fact. But is radiological dating, this isotope dating, carbon dating, or any other heavy metal dating, does this have application only to find out historical facts or just to find out which dino existed when? Actually, it does have other modern day applications also. Let's take a trivial example. You want to know how many fish exist in a pond. Now, you fish out certain amount of fish and then label them, tag them with a radioactive substance, and then again put them back into the pond. Then again fish a certain amount of fish from that pond. Now, Now doing some analytical chemistry with this tagged, radio tagged fish, by taking the ratio of tagged fish and the percentage of the fish in the sample, we can estimate the population of all fish in that pond. These are some cool applications. Now, also, if you want to know, let's say you want to know how much blood does a horse have without killing it. Now, you may inject some radio-labeled sample into the horse, and then it goes into entire its bloodstream. Then again, you may withdraw certain blood from it, and then analyzing the ratio of the tagged radio-labeled sample in the blood prior to injection and after injection, you can estimate the blood content of a horse. So thus, our chemistry, these various concepts of chemistry, like the kinetics, the decay, the analytical methods, all these have real life applications to solve some cool problems of life, cool mysteries of life. Thus, chemistry is fun.